Today we're looking at lesson 3.1, which is ultimately going to ask you to graph linear equations. We're also going to look at linear equations and intercepts and how we can use that to help us graph, as well as writing a linear equation in standard form. Here we're asked to determine whether each equation is a linear equation. When we think of a linear equation, that means when we graph it, it needs to make a straight line. So there are certain things that we need to look for, and then we need to be able to write the equation in standard form, which would mean that each coefficient, so in this case 1/3, needs to be a integer. So it cannot be a fraction or a decimal. So to make this into an integer, we would need to multiply by the reciprocal. Which would then make this become 1, y, or just y, equals -1 times 3. So we could write y equals -3. And this is the only part of the equation that we have. So this is our final equation, and that's as best as we can to put it into standard form. Mainly, the reason we changed anything was really just because the coefficient needed to not be a fraction. It had to be a whole number. The other part of this is to think about whether this is linear or not. So if I think about graphing this on a graph, it would be going through y equals -3, and it would be a straight horizontal line through -3, which would also make it linear. So you would say this is linear, and the equation in standard form would be y equals -3. This one we also have to determine whether this is linear or not, and if it is, to write it into standard form. The thing that we'll point out here is the squared, okay, this 2 here. Whenever a variable is squared, it's going to be graphed as a curved line. This is actually a quadratic equation, which we'll learn about later on in the year, but what you need to pay attention to is the fact that it has a squared with the x. If it was a squared with the y, it would be the same idea, because this is going to be curved and it's going to be not a straight line. So I would say no, this is not a linear equation. Here we're asked to find the x-intercept and the y-intercept, and we've talked about this in the past, but the intercepts are where the line that you graph crosses either the x-axis for the x-intercept, which would be here, or the y-axis for the y-intercept. So in this case, if we look at our line, it looks like it's coming from the 150 and horizontally moving to the right. So if we were to say the x-intercept, it actually is never going to cross the x-axis because it will continue to be a straight line off the page and will not dip down. So this would be 0 for our x-intercept. Our y-intercept, again, is where it crosses the y-axis. So in this case, it's crossing at 150, or it will cross at 150. So 150 is our y-intercept. We're going to next look at a table that shows a function relating the distance to an amusement park in miles and the time in hours the Torres family has driven. We're supposed to find the x and y intercepts, and then we're supposed to describe what the intercepts mean in the situation. So if we look at the table, when you are talking about intercepts, usually if it's the x-intercept, or always, not usually, if it's the x-intercept, the y coordinate of the point, if we think of ordered pairs, is going to be 0. If it's the x-intercept, I think I just said that, sorry. If it's the y-intercept, the x is going to be 0. So if we look at our table here and we're trying to figure out intercepts, I'm going to look for zeros right here and right here. I just need to determine which is the x and which is the y. So this, again, we've done before. We need to think about whether it's an independent variable or a dependent variable. So think about the time it takes to travel a certain distance. Well, the time it takes to travel that distance is going to depend on how many miles that it takes to get there. So the more miles, the more time it's going to be to get there. So in this case, the distance is going to depend on, the time is going to depend on the distance. Let me scratch that. Here, let's go back to the beginning. Sorry. It says the table shows the function relating the distance to an amusement park in miles and the time in hours. Oh, I'm sorry. Look, I found it. Has driven. Okay? So in this case, the time is not going to depend on the distance. The distance that they've driven is going to depend on how much they've driven already. Okay, so that would make this x and this y. And y is always your dependent variable, so that makes distance dependent. But what we need to focus on really is the ordered pairs. We have the first ordered pair, which would be 0 to 48, because we set up our ordered pairs x, comma, y. And then the last ordered pair that we need to focus on is 4, 0. So one of these is going to be your x-intercept, one is going to be your y-intercept, depending on where the 0 is. So since the first one, the 0 is for your x-coordinate, that makes 248 your y-intercept. And then since your y-coordinate for the last ordered pair is 0, that makes 4 your x-intercept. So basically what you're looking out for is when one of the coordinates is 0. If you're trying to pick out which was your x-coordinate, your x-intercept, and which is your y-intercept. Here we're going to graph the equation using the x and y-intercepts, so we first need to find them. Again, keep in mind that one is going to be 0 if you're going to find the other one. So if I'm going to find, let's say, the x-intercept, I'm going to plug in y for 0. So I need to find the intercepts first by plugging in y into my equation as 0. And solving for x. So I have negative x plus 2 times 0, which is 0. So negative x equals 3. I can't have a negative variable, so I'm going to divide both sides by negative 1. So x would be negative 3. So that would be my x-intercept. I would write that as a point, negative 3, 0. Then I would need to find my y-intercept by doing the same thing, just plugging in 0 for x this time. So negative 3, 0, we'll keep that in mind. And now we're going to plug in 0 for x to find our y-intercept. So 0 plus 2y is just 2y equals 3, and I would divide by 2 to get y by itself. So y is 3/2, or you can write that as 1.5, and that's going to be my y-coordinate. Because 3/2 is the same thing as 1.5. Or 1.5, so that's why I wrote 1.5. And then 0 is my x-coordinate. So if I were to graph the equation, I would use these 2 points and connect them with a line. So let me graph that. So I'm going to go to -3 on the x-axis. Which is here. I'm going to put a point, and then I'm going to go to 0, 1.5, which would go about in the middle here. And I'm going to connect the 2 points. So that would be my graphed equation. I'm going to do the same thing here for the next problem. So first we need to find each intercept by plugging in 0 for the other variable. So we're going to plug in, let's start with plugging in y as 0, solving for x. We need to add the 5 first to get x by itself. 5 would be equal to -x, and remember we can't have a negative variable, so we divide by -1, which makes it -5. So my x coordinate is -5, and my y coordinate would be 0. And I'm going to do the same thing with finding my my y intercept. So I'm going to plug in 0 for x. So y is actually also -5. So this point would be 0, -5. So I'm going to plot these 2 points. One point at -5, 0, and one point at 0, -5, and I would connect the 2 points to make my line. Next, we're going to graph the equation by making a table. So this is like your T-charts that you did for your project. We're going to have an X column and a Y column. You can choose points that you like for your X coordinates, so I always go with 0, 1, 2, 3, 4. And then to find my Y coordinates, I just plug in each X coordinate into the equation. So 2 times 0 would be 0. 0 minus y is 2, so -y, we need a positive y, so we need to divide by -1. So y would be -2, and I'm going to just keep going. So x would be 1, oops, and I'd plug in x is 1. To find y. So 2 minus y equals 2. I have to get y by itself. So I get -y equals 0. Now, even if I divide 0 by -1, it's still not going to be -0, so my answer there is just 0. And I continue with the next numbers. Next we're going to try 2, so 2 times 2. 4 minus y equals 2. And we're going to subtract the 4. And then divide by negative 1. So y would be positive 2. And we keep going with the last two. Plugging in 3. Subtract 6. And then divide by negative 1. So y would be 4. Should also start to see a pattern. It looks like each time it's going up by 2, so in that case I can assume that the last one is also jumping by 2 because this is a linear equation. So a linear equation is going to have a pattern in its coordinates. So what I'm going to graph is I'm going to graph these 5 points. Okay, so 0, negative 2, 1, 0, oops, 2, 2, 3, 4, and 4, 6. And I'm going to plot that on my graph. And for the sake of space, I'm not going to write the numbers, but each line is going to represent 1. So I'm going to put a point at 0, negative 2. That's going to be right here. Oops. Right here. Then another point at 1, 0. And then another point at 2, 2. Oh my gosh. Sorry. Then another point at 3, 4. And finally another point at 4, 6. And this should make a straight line if we graphed it correctly. And that would be our graph. We're going to do the same thing with these two, but remember, on your projects, I did not ask you to write a t-chart for the x equations and the y equations because they were all going to be the same value for x or the same value for y. So in this case, you don't have to do a table. You would just go to where x equals 3 on your graph, which is right here. You could put a point to help you, but then you would just draw a vertical line right through x equals 3, and that would be your graph. And then same thing for, let me make this pink. And then same thing for this one, except we'd go to y equals negative 2, right here. And again, we're drawing a straight horizontal line at y equals negative 2, and that's going to be our equation. So again, you don't need to write a table for that. And that concludes Lesson 3.3.